Hello and welcome to Mrs. Law's class. In this lesson, I'm going to do a quick review of sequences and then particularly a review of arithmetic sequences and series. So a sequence is a set of numbers arranged in an order with a first term, which we'll call T1, a second term, which we'll call T2, a third term, T3, and so on. So let's say we have this sequence 1, 4, 9, 16, and 25. So T1 is 1, T2 is 2, T3 is 9, T4 is 16, T5 is 25. So if we wanted to write Tn, that would mean we want to write like a general formula for the sequence. So we can see that these 5 numbers are perfect squares, and the term number tells us what number we're going to square. So the nth term would be n squared. Sorry, I apologize for any thumping you hear in the background because our neighbors are building a house. So hopefully you can still hear me quite well. All right, so an explicit formula is what we just wrote. It's a formula that describes the nth term of a sequence explicitly. So it can be used to find any term. So this example that we just did with Tn equals n squared, we know how to find the term. We just plug in whatever that little subscript is into the formula. Now a recursive formula, which we'll take a look at next, is a formula that relates each term of a sequence to the previous term. Now a very common sequence that you might know is the Fibonacci sequence. So the Fibonacci sequence is 1, 1, 2, 3, 5, 8, and so on. So if you look and see if you can find the pattern, okay, give you a couple of seconds to do that. So the pattern is that we take the 2 previous terms to get the next term. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. So here we see that the first term is 1, and we also need the second term, which is also 1 in this case. So the nth term we can say is t n minus 1. So we need the previous term, plus we need the previous second term before that. So plus t and then n minus 2. So this is recursive because we need terms before to figure out the current term. So this one's not as nice of a formula because if we don't know the previous terms, then we can't find our current term. Whereas in an explicit formula, we can find any term. So even if I ask you to find the 100th term of this first sequence of perfect squares, you can find it without having to know the previous terms. All right, let's next review arithmetic sequences and series. So an arithmetic sequence is a special type of sequence that has a constant common difference, which we'll call D, between successive terms. So if you take a look at this sequence here, we have 2, 5, 8, and 11. We can see that the difference between all of these numbers, so 5 minus 2, or we can go 8 minus 5, or we can go 11 minus 8. All of the differences are 3. So if you recall, the formula for an arithmetic sequence is the first term, T1, plus n minus 1 times D. So T1 is our first term. N is the number of terms. D is the difference. Sometimes people call it the common difference between the terms. And n, or Tn, is our nth term. All right, we're going to do an example, which I'll write on the side here. So let's say in the sequence of 2, 5, 8, and 11, I'm going to ask you to find the 10th term. Okay. So we are going to go T10. So the formula says we need the first term. So the first term is 2 plus n minus 1 because I want you to find the 10th term. That means there are 10 terms. So 10 minus 1 in our formula times d, and our difference here is 3, which we calculated before. So we have 2 plus 9 times 3. So we have 2 plus 27, which is then 29. So the 10th term in the sequence of 2, 5, 8, and 11 would be 29. All right, the next definition is the word series. So series is the sum of the terms of a sequence. So if you hear the word series in math, it means the sum of all the terms. So here, if I have 2, 5, 8, 11, 14, and I ask you to find S5, that means I want you to find the sum of 2 plus 5 plus 8 plus 11 plus 14. And then you can find out that answer, which you can use your calculator or you can add it up in your head, and you will get 40. Okay. Now the formula for the arithmetic series is a little bit more complex. So it's n divided by 2, and then in square brackets times 2t1 plus n minus 1 times d. Okay, so same as before, t1 is our first term. N is the number of terms. D is again the difference. And Sn, the S stands for the sum of n terms. So if I say S12, we would say the sum of 12 terms and so on. All right, so let's practice using this formula, and I'm going to do this on this question here of the series of numbers. So I want you to find the sum of 5 terms. So S sub 5. So in this sequence we have 5 terms, so it'll be 5 divided by 2. And then 2, our first term is 2, so 2 times 2. And then n is 5, so 5 minus 1. And our common difference, which we found from before, is 3. So you can type all of this into your calculator, or you can do some parts in your head first before you type it out. So 2 times 2 is 4. 5 minus 1 is 4, times 3 is 12. So we get 5 over 2. So that's going to be times 16. We can actually reduce here, so this crosses off and becomes 8. So 5 times 8 is 40, which is the same as what we got when we actually used our calculator and just added up the 5 numbers. Now the formula is helpful if we had more than 5 numbers. Let's say we had 100 of them, right? Then it would be easier to actually use the formula instead of adding up 100 different numbers. All right, so hopefully that was a quick review of sequences and arithmetic sequences and series.